Chapter 1.5.9 Topology-Aware Routing. The feature in Kubernetes v1.23, formerly known as Topology-Aware Hints, is now called Topology-Aware Routing. This feature adjusts routing behavior to prioritize keeping traffic within the zone it originated from, potentially reducing costs and improving network performance. It aims to optimize traffic flow for better efficiency. Motivation. Kubernetes clusters are often found in multi-zone setups, making it important to keep traffic within its originating zone. Topology-aware routing is a feature that helps achieve this by assigning endpoints to specific zones based on their region and zone data. The endpoint slice controller calculates these assignments and provides hints to cluster components like kubeproxy, which can then prioritize routing traffic to endpoints within the same zone for better performance and efficiency. Enabling topology-aware routing. Prior to Kubernetes version 1.27, the behavior of topology-aware routing for a service was controlled using the service.kubernetes.io/topology-aware hints annotation. This can now be enabled by setting the service.kubernetes.io/topology mode annotation to auto. This feature populates topology hints on endpoint slices to allocate individual endpoints to specific zones when enough endpoints are available in each zone. This results in traffic being routed closer to its origin. When it works best. This feature is most effective when incoming traffic is evenly distributed and when the service has 3 or more endpoints per zone. If a large proportion of traffic originates from a single zone, it could overload the allocated endpoints. In a cluster with less than 3 endpoints per zone, there is a high probability that the endpoint slice controller will not be able to evenly allocate endpoints. How it works. The auto heuristic is a method for allocating endpoints proportionally to each zone, best suited for services with many endpoints. The endpoint slice controller is responsible for setting hints on endpoint slices when this heuristic is enabled, allocating a proportional amount of endpoints based on the allocatable CPU cores for nodes in each zone. The kubeproxy filters endpoints based on these hints, usually routing traffic to endpoints in the same zone, but occasionally routing traffic to endpoints in different zones for better distribution. This helps ensure that traffic is evenly distributed across zones. Safeguards. The Kubernetes control plane and kubeproxy have safeguard rules in place before using topology-aware hints. If there are an insufficient number of endpoints compared to zones in the cluster, no hints will be assigned. In cases where balanced endpoint allocation among zones is impossible, the controller will not assign hints. The controller also considers the expected overload value for each zone without real-time feedback to prevent overload. If nodes do not have necessary labels or information, no topology-aware endpoint hints will be set. If endpoints do not have zone hints, the kubeproxy assumes a transition is happening and uses all endpoints. If a zone is not represented in hints, endpoints from all zones are used. This is common when adding a new zone to an existing cluster. Constraints. Topology-aware hints are not used when the internal traffic policy is set to local on a service, but can be used on different services in the same cluster. This approach may not work well for services with a large proportion of traffic from specific zones. The endpoint slice controller ignores unready nodes and nodes with certain labels, potentially causing unintended consequences if many nodes are unready. Tolerations are not taken into account by the endpoint slice controller, which may affect deployments limited to specific nodes. This may not work well with autoscaling, as traffic originating from a single zone may not be distributed effectively, leading to issues with the horizontal pod autoscaler. Custom heuristics. Kubernetes is deployed in various ways, making it difficult to allocate endpoints to zones using a single heuristic that fits all use cases. Custom heuristics can be developed if the built-in one doesn't work for a specific situation. The 1.27 release includes initial steps to enable custom heuristics, but it may not cover all relevant scenarios. The primary goal is to allow for flexibility in endpoint allocation based on individual needs.